Hey, so I said in one of the Flat Earth YouTube Hangouts side chats that I was going to do a Flat Earth math series. So I'm actually going to start that, and I'm going to do a video to say I did it, because technically one video is a series, it's not much of a series, because I'm a man of my word. But if I assume no one's going to care, so I'm only going to have to do one video unless people ask for it. So that's the math I've done when I did the video before, but now I'm going to do it fresh for you. So if you take the Earth as a sphere as an assumption, then you can take a sphere and slice it in half, and then the part you remain, and you can see how you'll have a circle remaining. Right? So you cut an orange in half and you get like a circle. So then you assume you have your eye at some point above the surface of the Earth. Every circle has a center. Every circle has a radius length. Why am I drawing that line? It's too early for that line. So you assume your eye is a certain point above the surface of the Earth, and you assume that you have a given length to some distant object. So really, right, we've got 2 points on the Earth's surface, and you got a height above one of them. But this is all just a 2D problem. So now I draw a line from the center of the Earth to this point of our observed object, or the latitude and longitude point of this observed object. But now here's a trick, right? Like when your eye is here, just imagine if I had a line or a piece of plywood or something, a pipe, and I just hang it here, and then I'll just let it drop. It's going to rest at exactly one point. It's going to rest exactly here. Say there's exactly one tangent line to the when you have a point and a circle. There's exactly one tangent line when the point is outside the circle. So we draw that tangent line, and then we can connect that to there, and this point is all... Make the points nice, big, and fat. Right, so the tangent line means right angles. Right? Right angles is what that means. There's a proof of that somewhere. So now these are radius lengths here. And then what are we given? Because we're doing a curve calculator, and we want to know our givens. So x, this distance here, is a given. It's the height of your eye or your camera or whatever the hell you're looking from. And then if I call this arc length here m, the length of the arc from this point to this point, that'll be m. The length of the arc from this point to that point is going to be n. And then we can extend this line out here. Call this length here y. And y is the height of obscuration, the amount, right? So if you had an object that was standing here on the Earth, the y distance of it would be obscured. So then you can obviously, if the object is 100 meters tall and y is 50 meters, then 50 meters is obscured, kind of thing. So now there's really only 2 rules we got to apply here, and I'll show you those rules. So if we got a right triangle, you have an angle here, which I'll call A and G. Then you have a hypotenuse, which is the side opposite the right angle, and you have an adjacent side. You also have an opposite side here, but we don't use this in this. So now the rule is cosine of the angle equals adjacent over hypotenuse. Let's put AD over HY. So the important thing is you be able to see this pattern here. You see this template in this actual geometric drawing that we have, and just apply it. Oh my god, it's supposed to be a straight line. So, yeah, cosine of an angle is adjacent over hypotenuse. And then the other thing we're going to need is, say you have a arc of a circle. You have an angle here, and you have an arc length. and you have a radius. Well, in the same way that circumference equals 2 pi r, arc, just a smaller arc, this is, right, a smaller arc equals just your angle times your radius. So these are the two things we're going to apply. And I apologize if I write kind of messy. It's because I generally remember the meaning of the thing I wrote. And people like me tend to do that, and then people like me tend to go back over the notes later and have no idea what the fuck any of it means. That's why I type things up cleanly after I'm done. So, but I'm going to do a clean equation for you at the bottom at the end of this video. So given is going to be x, the height of the eye above the surface of the Earth. Now we're also given a certain radius of the Earth. It was just assumed as given. And then we're also given m plus n. I know it's weird that we're given the sum of two variables, but we've called them two variables, but we just work with it. And then what we're trying to find is y. And then we go to it. So now, really, the smart, intelligent people would just say y equals blah 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 and have it solved. But we got to do the work. So what is y equal to? Well, some function of x, r, and m plus n. We got to find that function. Alright. Let me just delete that because that's gonna, yeah. So we're just trying to find that rule for finding y given these three quantities. So we just start, well, what do we know about y? Let's just call this theta and call this alpha. So now we can use our cosine rule here, cosine of an angle, or in this case cosine of alpha is equal to r over r plus y. Just applying our rule, right? Adjacent over hypotenuse. Here's the right angle. Right, I know you kind of got to flip that triangle through the page kind of to see how it matches up here, but I've attempted this a number of times now, so to do a clean video, so I'm pretty good at flipping the triangle in my head. Anyway, so that means we can actually solve for y. Y equals, well, let's just solve, this equation is simple to solve for y. You just bring the r plus y over here and put the cosine alpha down here, and then subtract the r at the end, right? So when you write it out, you can check it, kind of r over cos alpha minus r. Alright, and that's right. And now, so we don't know, geez, I did it again. Cosine alpha minus r. Brackets are important. Yeah, r plus y goes with that. Okay, so we found y, or did we? No, because we don't know alpha. There's some other information we can get about alpha, and it's that we use this rule here. Arc equals the angle times the radius. Or, in other words, angle equals arc over radius. Let's just circle that as a rule to be applied. So if alpha is our angle, our arc is n, and our radius is little r. So we know r, but we don't know n. Well, now n, here's a little trick. N equals m plus n minus m. I mean, that's obviously true. But the thing is here, we know m plus n, that's a given. But we don't know m. So what can we say about m? Well, m equals m is equal to what? We use this rule here. Arc equals angle times radius. So m equals theta times r. But we don't know theta. So now we do know that the cosine of theta here equals r over r plus x. So then theta equals r cos. I just write ACOS. That's the function I like to, for the inverse cosine function. Equals a cosine of r over r plus x. For some reason I'm doubting myself. Cosine theta equals r over r plus x, but no, that's correct. So we're actually like done at this point now, because we've written y is equal to this. Everything is known except alpha, but alpha is a function of these variables. R is known, but n is not. So we write down what n is, and n is equal to this thing we're given, m plus n minus m. But m is the only unknown in this equation, so we just write what m is equal to, and then m is equal to theta times r. We know r, but we don't know theta. Because our r's are given, right? We know our givens, but we don't know theta, and theta is equal to r cos of r over r plus x. The only variables in this equation are r and x, both of which we know. So right, so you can see how we've gone down the line and we've found y, but to make this useful, the format that's useful, I will put it all together. So we're going to write here, yes, this is the way I should do it. Theta equals a cos of r over r plus x, r over r plus x times r. Right, because all we did, we just substituted for theta there. So that implies n equals m plus n minus a cos r over r plus x times r. Now we're trying to find y, but we're going backwards for our chain, right? Once we got to this step here, m equals theta, or theta equals r cos of r plus x, we were done, but we know we just got to tidy it up. So now n equals that. That implies alpha equals, we got to write out this big dirty expression for n plus n minus a cos r over r plus x, r all over r. I can't leave that line like that, not in good conscience. R, right? So n, this big dirty expression, over r. This little line here so that we can distinguish those two. I know you shouldn't talk about your writing medium. The point is supposed to be what's talked about, but I'm thinking about my writing medium a lot. So alpha is equal to that. Oh my god, now I gotta plug it into that fucking equation. Oh, fuck's sakes. Implies y equals r over the cosine of, you know what, I can't believe I didn't think of this before. Select freeform selection. cosine of that. Now I know I didn't make a copying mistake. Let's tidy that up a little bit. Cosine of that. And that's r over all of that. And then that's r over cosine of alpha. Put our brackets are very useful. There, good enough. Minus r over cosine of alpha minus r. So then this is how a curve calculator works. Yeah, and now we can put a red box around our answer to make it easy for you to see. Right, so let's go back to black. M plus n. What happened? I right-clicked by mistake. M plus n minus r cos. Right, so we know m plus n. I fucked up that bracket. M plus n minus r cos. Alright, see, so it's now we're writing y in terms of everything that we know. This is all the curve calculator is about. There's different ways to do it, but you always get the same answer. Isn't that odd? Odd that math works that way.